Okay, 5.2 day one is simplify radicals. We have simplified radicals before, but now that we know things like third roots and fourth roots, we're going to try it again. Okay, the first one's the square root, which we've done before, just to remind you of the two methods most of you use. Okay, some of you think what you times to get 24, such that one of the factors is a perfect square, so that would be something like, oh, this is 4 times 6. The square root of 4 is 2, and then I would say, oh, this is 2 square root of 6. Some of you do a factor tree. So you think, what do you times to get 24? Maybe 2 and 12. 6 and 2 is 12. And then once you see that repeated factor, you know that's the perfect square. And then it goes like this. Okay, so we're going to do third roots and higher roots. And again, either method works, but because the numbers are higher, sometimes the factor tree is actually really helpful. So I'm doing the third root of 135. 135, I don't know off the top of my head the factors of 134. 5, since it ends in a 5, I for sure know it divides by 5. So I think I'm going to try to divide it by 5 so at least I can see what's left. Okay, feel free to use your calculator to do the division, but we are going to simplify by hand so that you can do it when you don't. So if I do 135 divided by 5, I'm left with 27. Now, if you recognize right away that the third root of 27 is 3, you can go straight to your answer, and I'll show you how you would write that. If you're like, oh shoot, 5's good, but let's do 9 and 3. This is 3 and 3. Okay, since this is a third root, I'm looking for 3 repeated factors, which would be the 3, 2, 3. Since there's 3 factors of 3, the 3 comes out. The leftover factor is the 5. So this would be 3 times the third root of 5. Okay, if you got to this point and you're like 5 times 27, wait, I know the third root of 27, you could have said, okay, this is the third root of 27 times the third root of 5. Third root of 27 is 3, and you would get the same answer. And I think most people will kind of use a combination of the two, depending on the number. Okay, let's look at the third root of 1,000. Okay, if you have no idea, let's just do something to get 1,000. What is it? 10 times 100? Oh, I can see the answer right there. 10, 10. I see 3 tens. So this is actually a perfect cube. The third root of 1,000 is just 10. Let's try the next ones. Okay, third root of 162. Okay, same. If you happen to know a factor right off, go ahead and use it. If not, we think of anything we can divide into 162. Since it's even, I'm going to divide by 2. 281. 81 is a nice number. 9, 9. Oh, I can see all the 3's coming out. Okay, so we're doing a third root. So I want a group of 3. I see 3 3's. I see my leftover factors as 3 and 2. Okay, so if you skip straight to the answer from here and you're like, okay, well, I had 3 to the third, so that's 3 on the outside. What's left in the radicand is the 2 times 3, so I'm going to go ahead and get a 6 here. Okay, if you want to list out the factors, we could do that too. Let's see, what do I have? 3 times 3 times 3 is 27. So this is 27 times 3 times 2 is 6. The third root of 27 is 3. Third root of 6, same answer. I think most people kind of do it a combination of the two ways, depending on what they notice first. Okay, 256. If you happen to know what 256 breaks into right away, you can totally divide it. If you have no idea, at least know it's even, so we can do 2 times something. And use a calculator to divide it, but do simplify it by hand so you'll learn how to. Okay, 256 divided by 2 is 128. Let's go again. What can I do? 8 times 8. Okay, this is a fourth root, so I need 4 repeated factors. 2, 4, 2, 4. I already see a lot of 2's, which is coming out nicely. 2, 2, 2, 2. Okay, fourth root. So let's see if I have 4 2's. Well, I have 4 down here, so I can already tell a 2 is going to come out. Okay, what am I left with? I have a 2, 2, and a third 2. So 2 times 2 times 2, that's 8. So I'm left with the fourth root of 8. Okay, third root of negative 216. Okay, if you recognize the answer right off, you're welcome to write it. Okay, if you have no idea, you're just going to divide by something. What should I do? 2 and 108. I'm going to worry about the negative later. Okay, if you have no idea, go with 2 again. Eventually it'll come to something else. Oh, there we go. 2 and 27. Okay, what are we doing? A third root? Okay, so I already see that there are 3 2's here. So the 2 is going to come up. Okay, now I have a 27. I know the third root of 27 is 3. So if you know that, you can just say this is 2 times 3. This is a negative. This is the third root of a negative, which is allowed. I'm going to get a negative answer. If you want to break your factor tree down more, I could make my 27 go 9 times 3, which is going to give me the 3 times 3, which is how I figured out that there were 3 of these. Okay, and if you just happen to notice right away that negative 6 to the third power is negative 216, you could have gone straight to the answer. Okay, now let's add some variables into our equations. Okay, I'm still doing square root. So 98, what is 98? When have no idea, do 2 times something. 2 times, okay, 49 is nice, so let's go like this. 49 times 2k. I know the square root of 49 is 7. The square root of 2k, I don't know. So let's leave it like that. Okay, that's a nice answer. Okay, let's try third root of 64. Okay, I'm going to worry about the y in a second, but I'll do the 64 first. If you know the third root of 64, you can go straight to the answer. If you don't, we will figure it out. What is it, 8 times 8? 4 times 2. 4 times 2. If you notice this is 4 times 4 times 4, the answer is 4. If you don't, we'll break it down more. Okay, so I have these 2's, I have these 2's. So I have 2 2's, which is going to bring it down to 4. Okay, now I would probably simplify this in my head, but I'm going to do it in pieces. Okay, now I have y to the 6th. Now if I have y to the third root and the y to the third will cancel. But I have y to the 6th, so I actually have y to the third. And I have another y to the third to make y to the 6th. Okay, let me see what I'm left with. Okay, if I do the third root of y to the third, the root and the exponent cancel and it leaves me with a y. If I do the third root of the next y to the third, I'm also left with a y. So my final answer is 4y squared. Okay, let's try the next one. 128. I'm going to worry about the number first. What is that? 2 times 64? What am I doing? Fourth root. I need 4 of the same factor. Okay, let me see if I have 4 of the same factor. I have 1, 2, 3, 4. Okay, so I for sure have a 2 on the outside. What am I left with? I have 2 times 2 times 2, so I have 8, which is not quite enough. Okay, so I have an 8 left in here, but I also have an n to the 8th, which I could rewrite as n to the 4th times n to the 4th, or some of you are going to be able to simplify that without doing it out like that. Okay, now the 4th root of n to the 4th is n, and the 4th root of n to the 4th is still n. That 8 is going to be stuck in there, though. So I'm getting 2n to the 2nd times the 4th root of 8. Okay, and if you can tell that the 4th root of n to the 8th is n squared, you could also take it out there. The reason that's true is because if I do n to the 8th to the 4th root, that's to the 1/4. And 8 times 1/4 is 2. Okay, let's keep going. 2, 2, 4. When in doubt, divide by 2. 112. Let's do 2 again. Actually, I know some numbers here. Let's try 4, 2. What are we doing? A fifth root? Okay, I need 5 of a single factor. So I have 1, 2, 3, 4, 5. Okay, so the 2 is going to come out. What's going to stay in? The 7 is going to stay in. Okay, fifth root of 7. Now for the t's, I do have t to the fifth, but then I have 2 more of them. Okay, so the 2 is going to stay. The fifth root of t to the fifth is t, but inside the radical, I'm going to have to keep this 7 and the t squared. Okay, let's try 24. 4, 6, 2, 2, 2, 3. No, 2, 3. We're doing a third root. So the third root of 8 is 2. The third root times 3. Okay, I didn't do the m to the third yet, although I guess I could have. The third root of m to the third is just m, so this is going to turn into 2m times the third root of 3. And I could have done that in one step if I had paid attention to my variables. Okay, let's try one more. The third root of 125. Actually, I know that's 5. I'm going to put 5. Okay, now for the x to the 12th. If you happen to know that that's x to the third times x to the third times x to the third times x to the third, then the third root of x to the 12th is x to the fourth. And you could write that straight in. If that freaks you out, then we're just going to add them up. 3, 6, 9. Oops, don't write 9. Add it up to 9, 12. Okay. The roots and the exponents cancel, so I'm left 1, 2, 3, 4, and I get 5x to the fourth. And you might have a different number of steps depending on how comfortable you are with exponents. Okay, in the last section, we're going to just mix it all up, but also do lots of variables. We're going to see if we can do some of them in our head. Should we? Here, I'm going to show a step, but then I'll say that, see how I would do it in my head. Since this is a third root, I want m to the third, but I'm going to have m to the second left. For n to the sixth, that's n to the third, n to the third. And then for p to the 10th, 3, 6, 9, and then I have an extra 10. Okay, let's see what this turns out to be. Oops, okay, so I can take out, which ones can I take out? I can take out the m, the n, the p, and the p. Okay, let's take all those out. So I take out an m, n, and then a p, so p cubed. Okay, and then left in the radical, I have the m squared and an extra p. Okay, let me try the next one and see if I can do it with fewer steps. Okay, the fourth root of x to the third. Okay, if I do the fourth root of x to the fourth, what do I get? I get x to the second. Okay, let's go to the next one. If I do the fourth root of y to the seventh, I mean, I can for sure take out a y. The question is, what's left after I take out the y? Well, I canceled out the y to the fourth, which means I should have y to the third left. Okay, now for the z, 4, 8, 12, I can take out z to the third. Okay, now after I take out the fourth root of z to the 12th, what am I left with? I have one extra z. Okay, so if you're comfortable trying to do it in your head, you can. If not, you could write it out like this. I would do x to the fourth, y to the fourth, y to the third, and z to the fourth times an extra z, and I'll get the same answers. Let's try the fifth root of 4. I mean, 4 is just 2 times 2, so we're going to leave that alone. Okay, what about the a to the 8th? Okay, well, if I make that a to the 5th, I can take out an a. What am I left with? A to the 3rd. Okay, let's go to the b. 14, 5, 10. I can take out b squared. And then what am I left with? B to the fourth. Okay, now c to the fifth. If I do the fifth root of c to the fifth, I just get a c. Okay, let's try the next one. Okay, third root of 16. If you happen to know the factor, we could go, but that's okay. The third root of 8 is 2. 1, 2. So it's 2 to the third. So the third root of 2 to the third is going to give me a 2 on the outside and a 2 left on the inside. Okay, let me go to the a. Doing third root. Third root of a to the third is just a. Okay, what about b to the eighth? Well, b to the third, b to the third. So I can take out b squared. And then what am I left with? B squared. Okay, 56. And again, if you instantly know the factor, that's the cube root, you can just do that. Like I know it's the 8. That third root of 8 is 2. Here, I'll do it how I would do it. I'd be like, okay, the third root of 8 times 7. Here, I'll break down the x's again. I'll show more steps. X to the third, x squared. And then what do I have? This extra y. Okay, so what can I take out? The third root of 8 is 2. The third root of x cubed is x. And then everything else is going to stay in there. Okay, let's look at f. Okay, it's not even, but it for sure divides by 5, so let's divide it by 5. Okay, 81 looks very promising. If you know that the fourth root of 8 is 3, you could take the 3 out instantly, or you could keep breaking it down. Okay, so what am I left with? I have a 5. What about the fourth root of x to the third? No, that's not enough to take anything out. Okay, but about the fourth root of y to the second? No, I don't have at least 4 of them, so I'm going to have to keep it in. Okay, a couple more. What is that, 8 times 5? Okay, what is 40? 8 times 5, the third root of 8 is 2. 8, 5. Okay, for a to the fourth, that's a to the third times a, so I can take out an a, but I'm stuck with an a. Okay, how about b to the eighth? B to the third, b to the third, I can take out b squared, but then I'm stuck with a b squared. Okay, 128. And same, if you recognize the factor faster, that's fine. Okay, let's count them up. I need 4. Here's 4. And then what am I left with? 1, 2, 3. Okay, so I can take out 1, 2, but I'm left with 2 to the third, which is 8. Okay, for the x's, I have x to the seventh, so I take out an x, but I'm left with x to the third. For the y's, I can take out a y, but I'm left with y to the third. Okay, and remember on these, you can show more steps if you want. Sometimes it helps. Some people can kind of spot the patterns faster.